Sometimes the most elegant solutions to massive industrial problems come from the strangest places. Today, we're going to talk about a beautiful little quirk of physics that helps oil refineries turn what is essentially waste into serious wealth.
So that's really the question we're diving into here. It's a fantastic story about transforming something almost worthless into a premium product, not with brute force, but with some seriously elegant science.
Okay, so every great story has a challenge, right? And inside an oil refinery, that challenge, well, it's found literally at the bottom of the barrel. I want you to meet our problem. It's called vacuum residue. Just think of it as the thick, sticky sludge that's left over after all the good stuff. All the lighter, more valuable parts of crude oil have been boiled off. It's thick, it's full of gunk like metals and sulfur, and for a long, long time, it's been a real headache to deal with. But here's the crazy part. Buried inside all that thick, dirty, low-value stuff is a hidden prize, de-asphalted oil, or what they call DAO. And this stuff is the complete opposite. It's clean, it's high quality, and it is incredibly valuable. So the whole game is figuring out how to get it out without spending a fortune to do it. For the longest time, the solution was really more about muscle than it was about brains. Let's take a look at the old way of doing things. The old school method was pretty much a brute force attack. You'd pump in just enormous amounts of a chemical solvent, and then you'd use a truly massive amount of energy to boil that solvent away just to get the DAO back. I mean, it worked, but it was just incredibly wasteful. This whole process creates something that engineers call a thermodynamic energy sink. I want you to imagine boiling a giant pot of water, but then you capture all the steam and immediately turn it back into water in the same pot, and you just do that over and over and over. You're just pouring energy and money into a cycle that goes nowhere. That's pretty much what the old method did, and it used a staggering amount of power. But then, a few clever engineers started looking at a really strange property of matter to find a better way. And this is where our story shifts from that brute force we were talking about to some real scientific elegance. This is what changes everything. The old way was all about boiling. The new way completely sidesteps it. But how on earth is that even possible? Well, the answer is in something called the critical point. See, every fluid has this one special, unique combination of temperature and pressure where the boundary between it being a liquid and it being a gas, just vanishes. It's gone. Exactly. Think about what that actually means. You're not dealing with a normal liquid anymore, and you're not dealing with a normal gas. You've actually created this weird, new, hybrid state of matter. That's really the best way to describe it. It's a supercritical fluid. It's this dense thing that flows, but it has properties of both a liquid and a gas at the same time. And this strange state, this is the key to the whole puzzle. So let's look at how this one process called ROSE, which stands for Residuum Oil Supercritical Extraction, just masterfully exploits this little physical anomaly. Okay, let's walk through this because it's pretty brilliant. First, you take a solvent, something like propane, and you push it into that supercritical state we just talked about. In the super dense phase, it acts like a really powerful liquid, and it dissolves all that valuable DAO right out of the residue. Now here comes the magic trick. All you do is increase the temperature just a little bit, and the density of that supercritical propane just plummets. It instantly becomes way less liquid-like, and the DAO, which can't stay dissolved anymore, just drops right out. It separates by itself just based on density. No boiling needed at all. So what does this all get you? Well, it creates this incredible cascade of advantages. You get a perfect separation without that massive energy bill from boiling. The whole process is also cleverly designed to capture and reuse its own heat, which slashes the need for external steam. And because you're not constantly boiling and condensing your solvent, the entire system is just way more stable and easier to control. So, what does this elegant bit of physics actually mean for the bottom line? Let's connect the science right back to the money. The result is, honestly, nothing short of brilliant. You take a low-value waste stream, and just by cleverly messing with the physical properties of a solvent, you can efficiently pull out an incredibly high-value product. It is the perfect marriage of efficiency and profitability. I really love this quote. It just nails it. This isn't just some mechanical filtering or boiling process. This is about deeply understanding the fundamental laws of thermodynamics and then turning that knowledge into a real competitive financial advantage.
And that's really the big takeaway here. This isn't some small, incremental improvement. It's a fundamental breakthrough in how refineries work, and it's all powered by a deep understanding of physics.
And that brings us to our final thought. That weird, beautiful anomaly of nature, that critical point, it isn't just a curiosity you find in a physics textbook. Out here in the real world, it's a powerful engine for creating value. It's not just physics, it's profit.